Our third example, we want to represent 1 over x as a power series. We want to center it at x equals 1 this time, so we know that we're going to need powers of x minus 1. All right, so we start off with this form. This is what we're aiming for, a over 1 minus r. So we're going to take this 1 over x. I'm going to make it look like that. So I have 1 plus x minus 1. So not only, in this case, not only do we get our x minus 1, right, but we actually offset the 1 that we needed here as well. So now we have 1 minus a negative x minus 1. So we've accomplished our objective of getting it in this form. Our a is 1, then we have 1 minus r, so minus our r is this negative times the quantity of x minus 1. Alright, so our series looks like this. This here is just another way of writing negative x minus 1 to the nth, the negative 1 to the n, x minus 1 to the n. Right? But that only converges when the absolute value of r is less than 1. So what we have here is the absolute value of negative x minus 1 is less than 1. So that means the absolute value of x minus 1 is less than 1. All right. So we're centered at 1. Our radius of convergence is 1. So our interval of convergence is going to be from 0 to 2. Right. We can also write it as this inequality here and accomplish the same thing or get to the same place. All right, example 4, we want to represent this function, 15 over 2x minus 1 as a power series, centered at x equals 2. So again, right away we think, okay, we're going to want powers of x minus 2, so x minus 2's to the nth power. This one's a little more complicated to get it in that form, right? If we start off thinking about the form we want to get it in, a over 1 minus r, we have 15 over 2x minus 1. I'm going to make it negative 1 plus 2x. So I'm going to aim at getting these x minus 2 powers first, right? So I'm going to take this 2, I'm going to kind of factor the 2 out and get my x minus 2. All right? When I subtract this 2 from the x, I'm really changing the value of this denominator by negative 4 because it multiplies by this 2 outside the parentheses. So to maintain that equality, I have to add 4 there. All right. That 4 then combines with a negative 1 to get 3. So I'm pretty close here. I have 3 plus 2 times the quantity x minus 2 in my denominator, and that 15 is still in the numerator. Now, to get it in this form, I need a 1 here. So I'm going to divide everything by 3. And get this. And then I want it to be 1 minus my r, so it's going to be 1 minus a negative 2/3 x minus 2. Right? So a is 5. My r is negative 2/3 x minus 2. My series is going to look like this. Right? This is just another way of saying that r to the n, negative 2/3 to the n, x minus 2 to the n. All right, and that series is only going to converge when the absolute value of negative 2/3 x minus 2 is less than 1. All right, so that means 2/3 x minus 2 is less than 1. Multiply the 3/2 over, so I get x minus 2, absolute value of x minus 2 is less than 3/2. So this is my radius of convergence. All right, and my power series is centered at x equals 2, so I'm going to go 2 minus 3/2, 2 plus 3/2. Here's my interval of convergence.